Okay, guys, so this is day two, and now we're moving into still working with the tangent ratio here, but now we're going to be looking at finding lengths. Okay, similar to what we did last year, um, but we're going to be working in section 2.2 today, still using tangent, so we haven't got into sine or cosine yet or any of that, but we will as we move ahead. If we uh, look ahead here, I think our next big one, yeah, would be there's a checkpoint in there, and then we get into sine and cosine ratios, and those get used at kind of the same time. Anyways, so today we're going to be looking at solving the adjacent side in the tangent ratio, solving the opposite side in the tangent ratio, and then basically doing some word problems. So again, be about a 30-minute instruction with some practice. Okay, first unit here for you guys being online, mainly, depending on how we're doing it this year. Okay, so let's go ahead and look at examples that solve the adjacent. Or let's see which one's easier. The opposite side is the easier one. So we'll start with the B part. Okay, and we'll do one word and one. So the word will kind of blend in with both of those. We'll do a drawn one and then a word example, and then maybe let you try one as well. So let's say that we have this triangle here. And let's say that in our triangle we have, I think I'm going to go with the calligrapher pen today. Okay, this is our right angle. This is our given in our right triangle. And we want to find, let's say we want to find that this is side X, and that they tell us that this angle here, angle A we'll say, is equal to, looks like about 24 degrees. Not 240, that's a degree sign. Make it better. Okay, so we got a 24 degree, and we know that this side here is 216 millimeters, we'll say. And it says find X to the nearest millimeter. Okay, so now what we should do is we should label this up as we know that this is the opposite side because it's opposite of the given angle A. This is the adjacent side because it's touching the angle and it's not the hypotenuse, because the hypotenuse is always opposite of the right angle. So then we are going to look at setting up our trig ratio, tangent. Okay, and we can just put in what they are. Tangent A, or tangent 24 degrees, is equal to the opposite, which is X, over the adjacent, which is A, which is 216 in this case. Okay, so if you were needing to write that formula out to remember it, it would look like tangent of angle A is equal to X over, or O over A. Opposite over adjacent, then we got X and 260, but you don't necessarily need to write that every time as long as you write this statement out. So then we have to solve for X. Solving for X, we have to multiply by 216 on both sides. So we're going to multiply by 216 here, and we're going to multiply by 216 here. So that's going to get rid of this. So that I've got tangent of 24 degrees times 216 Of course, that's millimeters, but we're going to write that in later. It's going to give us our x. Okay, so tangent of 216, we can just do that right on our calculator. Okay, so tangent of 216, pardon me, tangent of 24. So I'm going to write the decimal number down when I do it. Make sure you do at least 3 decimals, if not 4, when you're doing it, but you can just leave it on your calculator when you're doing it. So tangent 20, oops, I did sign. Tangent 24. If you got a forward calculator, you go tan 24. If I do that, I get 0.4452 and 216. So I'm just leaving that decimal number on my calculator, and I'm just going to multiply, and you see it went pretty far into the decimals, but that's okay, because we're going to round off at the end, times 216. So I get 96.16. Okay, according to the question, they want it to the nearest millimeter, so that would be 96 millimeters. Okay, so that's an example of doing an opposite side. Let's do an adjacent side. And then we'll maybe do some word problems as well. Okay, let's do an adjacent side. So let's say I have this triangle here, like a ramp. That one went over a little bit, but that's just to the point there. So, and let's say that we have, this is angle N, which equals, let's say that that's 18.8 degrees. Guess I should put the degrees at the end, not in the middle. That's just going to confuse myself there. 18.8 degrees. Okay, and let's say that this is raised up 1.62 meters. And I want to know what this side here is to the nearest meter. Find x to the nearest meter. Or I guess to the nearest hundredth of a meter. Nearest meter would be kind of silly. Okay. So this is pretty simple to do. It's just going to be a little bit of a different rearrange than the first question was. Okay. So if I move this down, let me move this down so we can get that near the top there. I'm going to see myself, okay, I'm going to use blue for this part. This is going to be our adjacent side because that's angle N right down here. It's touching it. This is our opposite side. And of course, because that's a hypotenuse across the way. Okay, so I'm looking at it going, okay, well, I know that tangent of N, which is 18.8 degrees, equals the opposite side, which is 1.62 meters, over the adjacent side, which is x. Okay, so we have to do a couple of steps to get x by itself because it's on the bottom of a fraction. So we've got to get that denominator out. So the first step you're going to do is multiply both sides by x. So we've got x times tan 18.8 equals 1.62. So you see that the x would cancel out there. Okay, so now we've got it off the bottom of a fraction. So now we can solve it by dividing this x times tangent. Okay, x times the tangent. So we got to remove that tangent part. So that's a dividing. So we're going to divide by tan 18.8 on both sides of our equation here. Make sure you put tan there. And this is going to get rid of the tangent here. So if we go over in this top corner here, we've got x is now equal to 1.62 divided by the tangent of 18.8. So we need to know what 18.8 tangent is as a decimal number so that we can do the dividing. So some calculators you can go 1.62 divide tan 18.8 equal, and they'll work if they're a forward bigger calculator. But some of the smaller, or sometimes the phone doesn't work that way. You have to get the tangent first and then divide the decimal number. So you have to be careful and you have to know your calculator. If you're not sure, you can always ask and we can try, or just try it out and see how it works. So I'm going to go tangent 18.8 on my calculator here and see what that number is. And I get 0.3404. I get, got to keep the 1.62 there. Okay, and then I get 0.3404. That's enough of a going down into decimals. And we can go 1.62 divided by 0.3404 equals 4 and we said to the nearest hundredth, 4.759. So this would be 4.76 meters. Okay, so that's finding the adjacent side. Okay, finding the opposite side, we did that already. So that gives us our two main examples of how to do those. So let me just double check here. Video time, we don't want to spend the whole class doing examples. We're at 12 and a half minutes. That's good. So this will be good time. I'll draw one out here and you pause it and try it, and then I will work it out. And then we'll go on to doing maybe a word example or two. Let's flip ahead here. Okay, so let's say we have this triangle here. Drawn for you, and I'm going to indicate that this is our right angle. This is angle K, which equals, actually, you know what? I'm going to use the bigger angle. I've been using the small angle the whole time. Let's try this one here. Let's say that angle K, let's say that this is 73.5 degrees, and that this is 916 millimeters. And I want you to find this raised part here. We'll call it W. Okay, so we'll do that. Let me just pause for a sec. Okay, so we're good there. Sorry about that. We're going to find this W, or funny W, I guess I made it there. Okay, so I would pause it, give it a whirl on your own, and then unpause and I'll be working it out. Okay, so let's do this. Okay, so we've got to identify our sides first. This is our opposite this time. This is our adjacent. And this is our hypotenuse, which we don't need until we get into sine and cosine, but we're going to get there tomorrow. Okay, so we've got tangent of K, which is 73.5. Okay, so that's our K value. That's going to be the opposite side, 916 millimeters over the variable W. Okay, so we're finding W there. So we're going to go to the nearest millimeter, I think. Okay, so we're going to multiply by W. and that's going to cancel that out. And then we're going to end up dividing out 73.5 degrees tangent on both sides. But I'll write the line in here. Okay, so we're going to divide out tan 73.5 degrees, tan 73.5 degrees. Okay, so let's figure out what our W is in millimeters. Let's do our tangent 73.5 degrees. I get 3.376. So this is going to be equal to 916 millimeters. And this is 3.376 if I round it off there. And that will give me an answer when I take my 916 and I divide it by 3.376 of 271 millimeters. All right, so that gets us to our final part of the instructional examples today, and that would be when you have to draw your own triangle based on some words, which can be the more difficult type of ones. So let's take a look at doing one of those, and then I'll give you some practice to work on in day 2. Okay, and then we'll keep going the next day as well. Okay, and we'll see how it goes for you. First week here is a shorter week, so we'll see how that goes. All right, we'll just move it down and we'll extend this a little bit. All right, so let's do a word problem example here. We'll type it in. So let's say that, let's go with a plane is 1,516 meters above the ground. Okay. You directly above a town. Okay, so the plane is hovering just kind of right above a town. Okay, and then it says you are some distance away from the town. And look up at, let's say, 15.9 degrees from the ground level, also known as angle of inclination. Okay, so 15.9 degrees looking up from the ground level to see the plane. Calculate your ground distance from the town to the nearest meter. Period. Okay, so there's an example of doing a word problem. So we have to set up our own. Okay, we're sitting around 20 minutes, so we're doing good. I'm going to, like I said, I'm going to try to do half an hour's for instruction, half an hour's for practice each day for this first unit that you guys are working through online here. Okay, so let's go ahead and draw this out. So here's our ground. Here's our town. Maybe I'll just use. Okay, here's our town. We've got some buildings. Okay, and then the plane is up here. Oh, that's a great plane. And we know that according to what we're told, you are over here some distance away from the town. Okay, and you look, let's use a straight line here. Okay, we know that directly above the town, we're going to go from here to here to the plane, and you also look from, and we're saying from ground level, so you don't have eyeballs in your feet, but just assuming that you're laying on the ground looking up or something like that. Okay, so if we label this up, here's a right angle where the town is. We know that this is 1,516 meters above the ground. You're looking up at 15.9 degrees, and you don't know what this distance, we'll call it D, from the town would be. Because, oops, sorry about that. Because you're looking up and you're trying to find that distance. You're not looking the distance from you to the plane, which would be the hypotenuse. You're looking the distance from you to the town, which is the ground distance. Okay, so now we're going to just set this up as a tangent. We'll call this A here so that we have a name for angle A. So we know that this is our opposite side. This is our adjacent side. I don't need to put the extra P's on it there. We'll just say O and our adjacent side. And this is our hypotenuse side. So the tangent of A, which is 15.9 degrees, is going to equal 1,516 meters over D. Okay, so this is the double step one here. So to get that distance, we're going to have to multiply by D on both sides. So we got D times the tan of 15.9 degrees equals 1516 meters, if we cancel those D's out. Okay, and then we're going to have to divide the tan 15.9 on both sides. All right, got it set up. This cancels out here. Okay, we will plug it in. All right, so let's figure out what tangent of 15.9 is. Oops, got that backwards. I got to do the tan first in mine. Okay, I end up with 20.2849. So D equals 1516 meters divided by 0.2849. And I get to the nearest meter 5,321 meters. Okay, so I am 5,321 meters from the town. Okay, so that gives us all of our examples that you're going to see in this section, okay, in terms of word problem examples and finding opposite side or adjacent side in tangent. Now, they only use tangent, and they throw in a funky one with where you have to use the hypotenuse. I do not think so in this case, but if they did, we did an example yesterday on that, and you can do the similar thing there. Okay, so I'll give you the practice. We're sitting at about 26 minutes, so that's about half a class, depending on how things go. And we'll go ahead and we'll slap some practice in here in section 2.2. So we're looking at page 82 and 83 and a little, oh, no, not even 84, shorter than the other one. Okay, and we're looking at doing some practice here. And we'll do 3, and we'll do the BD parts this time. So B and D. Okay. Well, that's kind of silly. Well, whatever. We'll do 4A and C because and 5A and C because there's no BD. There's only 3 of them, which is good, you know. Then we'll skip 6. We'll do 7 there. They kind of draw that one for you. We'll do 8. And finally, we should do one where they don't draw everything for you. And that's 14. So you got 3 word problems and 6 other problems. That shouldn't take you a whole period, or half a period, more than half a period, pardon me. And good luck on that. So I will post this up, and good luck. Remember, if you do have questions, please ask. Even if I'm working with the grade 9s or something, it's nothing to stop and help out. Plus, we'll probably have, because we're doing the first unit online here, we'll probably have a day where I just walk around and see how you guys are doing while the grade 9s are working on something. So that'll be coming as well. And good luck.